In this video, we are going to talk about how we can find the integration using the concept of change the order of integration. Let us move to example number 1. So here the question is evaluate integral 0 to 3, integral 0 to 2, 4 minus y power 2 dy dx by changing the order of integration. That means the given order is dy dx and I want to change the order of integration. So if you change the order of integration, this will become dx dy. And here if you notice the limit of y is nothing but 0 and 2. The limit of x are x equal to 0, x equal to 3. So all the four limits are constants. When all the four limits are constants, when you change the order, okay, the limit also going to change. That means in place of 0 to 2, you will write 0 to 3. So 0 to 3 now will become your innermost limit and 0 to 2 will come outside. But remember, the function does not change. You have the same function. Okay, now what is the meaning? This one I need to perform. So keep 0 to 2 as it is. Integration of 4 minus y power 2 into dx, that will give you 4x minus y square times x between the limits 0 to 3 and dy. So this will give you 0 to 2. We have to replace x by 3. So I will get 12 minus, if I replace x by 3 here, will give you 3y power 2. After upper limit, I have to write minus lower limit. Here the lower limit is 0. If I substitute x equal to 0 here and 0 here, this will become 0 into dy. So now what I do? I have to integrate this with respect to y. So integration of 12 with respect to y will give you 12y. Integration of minus 3y power 2 will give you minus 3y power 3 divided by 3. So cancel 3 and 3, substitute 0 and 2. If I apply upper limit 2 in place of y, will give you 24 minus 8 minus times lower limit 0. So if I simplify, 16 is the final answer. So remember, when I have two constant limits like this, then if I change the order, for example, if the question is dx dy, so you will change into dy dx. At the same time, change these two limits to outer side, change these two limits to the inner side. Remember, no need to change the function. So this is how we perform change of order of integration using all the four limits in terms of constants. Sometimes we are asking to change the limit using variable limits. So in this question we have given 0 to 1, 0 to x, some function f of x comma y dy dx. So step number 1, you have to list out the limits. So here this is y, so I have y equal to 0, then I have y equal to x. Then the outer limit in terms of x, which is nothing but x equal to 0 and x equal to 1. So this is your step number 1. Step number 2, you have to construct the region. For the region, write x-axis and y-axis. Remember, in x-axis always y equal to 0. Similarly, in y-axis always x equal to 0. So check my limit once again. My limits are y equal to 0. It is here. Then x equal to 0. It is here. Now I need to draw this one, y equal to x. What is y equal to x? This is nothing but a straight line passing through the origin like this. So this is my x equal to y. And then finally we have x equal to 1. What is x equal to 1? Draw a line parallel to x-axis like this. So this is my, not parallel, perpendicular to x-axis, I'm sorry, x equal to 1. So now this is my bounded region. The question is change the order of integration. So when I change the order, as I told you before, we no need to change the function. So keep the function as it is. What is the given order? The given order is dy dx. If I change the order, the problem will become dx dy. Okay, whenever you change the limits, the order of integration, the limit also going to change, because now we are dealing with variable limits. Okay, so we have to find the new limits. How to find the new limits? After changing the order, see the innermost variable. What is the variable here? X. So what I do, you have to draw a line which is parallel to x-axis. So here and here. So this left line touches x equal to y. So here my lower limit is y. Then right side it touches this line. So here my upper limit is 1. Then for limit of y, what I do, I have to move this line down. So after some time, if you see, this line will come down. Okay, just imagine this arrow will come down and it will lie down in the x-axis. I am looking for which value? I am looking for y value. In x-axis, the value of y is 0. So that is my lower limit. Then we keep on moving this strip little bit up. So it will land here, right? So what is this line? This line is nothing but y equal to 1. How I conclude this is y equal to 1? Because this line is x equal to 1 and this one is x equal to y. So if x value is equal to 1, definitely y value also equal to 1. So we fix 1 here. So my final answer is integral 0 to 1, integral y to 1, f of x comma y dx dy. Sometimes instead of f of x comma y, they will give you function. If function is given, you need to integrate and substitute the limits. Say for example, here the question is integral 0 to a, integral x to a, and the function is x power 2 y power 2 dy dx. The question is evaluate this integral by changing the order of integration. So what is step number 1? Step number 1, we have to write all the limits. So here y equal to x, y equal to a. So y equal to x, y equal to a. Then outer limit x equal to 0, x equal to a. So x equal to 0, x equal to a. Then step number 2, we have to construct the region. How to construct the region? X-axis, y-axis, here y equal to 0, here x equal to 0, then y equal to x, which is a straight line passing through the origin, and then y equal to a. So we draw a line here, this is y equal to a. Now this is my bounded region. Okay, what is step number 3? We have to change the order. When you change the order, again I'm repeating, no need to change the function. Just change the given order. The order is dy dx. If I change the order, this would become dx dy. So after changing, see the innermost limit, innermost integration with respect to x. So I have to draw a strip parallel to x-axis like this. So here left value 0, right value y. So we have 0 to y. Then slowly if I move down the strip here, it will land here. So here y equal to 0, lower limit. If I take the strip up, it will land here. Here y equal to a. And then we have to keep outer limit as it is, integrate this with respect to x. So integration of x power 2 will give you x power 3 by 3. Integration of y power 2 will give you y power 2x 0 to y dy. So substitute upper limit in place of x minus substitute in lower limit in place of x. That will give you some answer. That answer again you have to integrate with respect to y and substitute upper limit a minus substitute lower limit 0 will give you the final answer as a power 4 minus 3. Thank you.